All right, today we're going to do a review class, so please flip to lesson 1, assignment. So it's on page 227. And lesson 1 on page 227 started off with factoring just very basic equations. Okay, so in number 1, let's do 1c. How do we do this one? What structure is this? It's a trinomial, good, where a is 1. So then you just have to use inspection. So inspection, x, and then what two magic numbers multiply to 10 and add to 9? Has to be 10 and 1. Is this one even going to work? This one will not work because you would have to use a positive 10 and a minus 1. So this does not work. Why doesn't it work? That should be a negative 10 for that to work, right? Okay, so make sure you're aware that sum can't be factored. How about for part B? What would you write? Bracket, bracket, x, and then for B? 1 and 5. Because those are the only things that multiply to 5. And then those would add up to 6, so you'd be good. So that one's good. Okay, what about in 2e? What do you see here? Is it a trinomial? It's a binomial. So do you see perfect squares? But is x a square? So you got to take an x out. So that's the GCF part, right? So then you have 16x. Take out a 4. So x wasn't the GCF. 4x was the GCF. Good. So then 16 becomes 4, and this becomes 1. So is this a difference of squares? No, because 4 and 1 are squares, but x is not. Okay, so you just leave it like this. Okay, let's check out 3a. This one I believe was on one of the quizzes. So is it 10 minus a, 10 plus a, or is it a minus 10, a plus 10? Yeah, you got to start with the 10, right? See, the order is important. Don't go a minus 10, a plus 10. The 10 is the first term. Let's take a look at 3D. What would you have to do there first? Always anyway. What do you always do first? Check for a GCF. So in this case, you can only take out a x. Take out a x, and you get 9 minus 4x. Could you keep going on that one? No. What if this was 9x minus x cubed? Then this would become x squared. And then you could keep going on that, right? What would you have? 3 minus 2x, 3 plus 2x. Okay, good. Change that to a 3 and then do this answer this way so you don't forget that you can always keep going. Okay, shall we? Let's take a look at 3i. My recommendation, if you have a negative lead coefficient, get the negatives in a better spot. So factor out a negative. All these will switch signs. Is that in the proper order? Does that look normal? Okay, so keep the negative on the outside. Change the order of the inside. Now go ahead and factor. Now it looks more normal to me. I can factor that. There's a GCF? 4? Okay, take out a 4. What do you get? Okay, now the factors are 12. You got a late slip? Factors of 12. What are they? So they have a difference of positive 1. Or a sum. So it's 3 and 4, right? Which one's negative? The bigger one or the smaller one? So the bigger one's positive. Very nice. So that you end up with a plus 1. because 4 and a minus 3 gives plus 1. So that's lesson 1. Let's jump to lesson 2 probably. That's pretty straightforward, don't you think? I just want to give you a tip if you have a negative lead there. Okay, let's jump into lesson 2. Page 236. Can you guys pick one of these where you haven't? You've done them all? Oh my gosh. Page 236. Let's find one you haven't done. Page 236. Oh my gosh. Oh my gosh. Just taking a look at people's homework, I see a lot of people haven't done these. Okay, let's do 4B. Okay, let's do 4B. What do you see here? What kind of a polynomial is it? Trinomial where a is not 1. So can we use inspection? We have to use decomp. Good. So we need to find a way to break down the middle. So we get 4 terms and we can do 4-term grouping. So AC value is negative 24. What factors of 24 are going to have a separation of 2? 6 and 4. Which one's negative? Negative 4. Okay, so let's break this middle guy down. Plus a 6y minus a 4y minus a 3. Put it into factor groups, and you're going to grab GCF. Out of the first pair, you could take 2y. You get 4y plus 3. Now I see 4y and 3 on the other 2 terms, so I'm pretty happy right now. The only thing is that they're off by a sign, so factor out a negative 1. The numbers stay the same, but the signs will switch. Now that they have that common 4y plus 3, take that out, and you have 2y and a minus 1. So everybody with blank pages on this page, please attempt some of these tonight, please, before your exam tomorrow. You never want to be doing questions for the first time on an exam. You practice, 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 right? Okay, so that's decomp. Let's go to the next page. And let's do a decomp where it's looking really bizarre. Next page, question C. Page 237, question C here. You want to factor out a negative 1? Is that what you said? So let's take out a negative, and let's reorder it in the same step. Okay? That's what I would do. I would factor out a negative and reorder. Now what's the AC value? Negative 30. And how's that going to break down so you have a separation of 1, a difference or a sum of 1? They have to be off by 1, so it has to be 5 and 6. Which one's negative? The 6. Good. So keep the negative on the outside, 10a squared, and then we're going to replace minus 1a with minus 6a plus 5a minus 3. Keep the negative on the outside. Now we're going to have to break these into their GCFs. And we're going to have some double brackets, and that's okay. Just put a square bracket there to help you. Now what's going to come out of the first pair? A 2? A 2a, and then you get what you're talking about over there, 5a minus 3. And what do I need to take out of the second pair? Not nothing, a positive 1, which changes nothing. That's what you're going after when you said nothing. And now inside the square brackets, you have a 5a minus 3 being factored out and the 2a plus 1 remaining. And yours will be similar, it just has a negative inside. Good. Yeah. So you have a negative out here, that will become negative, that will become positive. It's the same. Okay, so when you go to tackle E, would you just do AC with 12 and 30, or would you try to simplify it first? Take out a GCF. Okay, good. So let's jump into another lesson. Oh, this stuff, before we go to the next lesson. Perfect squares. Perfect squares. What do you need to have a perfect square trinomial? Good. Kind of on the right track. The first and the last terms have to be squares. So that's a square. Is 50 a square? No. So this one's not a perfect square. Let's look at this one. Is this a square? Is this a square? Okay, you've met the first condition. Now if you were to FOIL or factor this, and you're using squares and square roots, this would be 4y, and this would be 4. This would be 4y, and this would be 4. It would have to be that way. Now when you go to double check, you can just check a FOIL. And because this is plus, these have to be plus. If that was minus, these would be minus. Now you check your FOIL. Okay, that's good. Okay, and then what happens here? You go 4 times 4 is 16y, and then you go 4 times 4 again, you get 16y. So it's the same, so they double up, and do you get that? So then this is a perfect square. Okay. So if you have an inkling or a suspicion that you might be dealing with a perfect square trinomial, write the 2 brackets, put in the roots in the specific spots, and then copy the sign of the middle term, and then FOIL it out and see if the middle term works out. You'll never get a study sheet information before the day of the exam. It's always like 2 minutes before. Okay, let's go to the next lesson. So this is where you have some more challenging. So this is page 244. Page 244. Let's find one that most people haven't done. Number 1, is there any that I should do? Probably not A, but most people got A. How about F? Let's do 1F. 1F looks challenging. Okay, page 244, 1F. You're looking at this and you're saying, wow, there's an x5. I haven't seen that before. But they all have x, right? And they all are divisible by 2. So that's amazing. Factor out 2x, you get x4 minus 8x squared plus 16. Now, even though this is x4, do you still have a trinomial? And is the a value 1? So then you can just use inspection. So how are you going to make 1x4? x2, x2. And then what makes 16 with a product and doubles up to negative 8? Positive 4 or negative 4? Am I done? No. What do you see? Difference of squares, x plus 2, x minus 2, x plus 2, x minus 2. And then you just kind of clean it up. Like that broke into these. Then you just sort of clean it up. You have 2 of these x plus 2 terms and 2 of these x minus 2 terms. I think, Ashton, you did that on a quiz. Hi. What's up? Yeah, that'd be perfect. Those bottom two lines are both perfect. I'd give you all the marks for this and all the marks for this. Yep. But I wouldn't give you all the marks for this step here. That if you got to here on a written response, it would be 1 out of 2. So all your tests have been structured the same way. It's a bunch of multiple choice, and then there's a bunch of written. And in the written, every question's worth 2 marks. The first mark, you will always get it if you start properly. And then you always get the second mark if you execute and finish it properly. Okay, and then sometimes I give like 1.5s if like you mess up a plus or a minus or something. And sometimes I give 0.5s if like you started it correctly, but there's still a minor mistake in there. Okay. Just so you guys know how you're getting marked. Number 2. Anybody do 2A? Or anybody not do 2A? So let's do 2D or something? If you want to work on your own because you've done all this, you can. Or you can pay attention. It's up to you. Which one? 2C? 2C. Okay, 2C. Okay, let's look at 2C. Is there a GCF? No GCF. Okay, so is it a trinomial? Yes. Okay, is the A value 1? No, so we have to use decomp. Okay, decomp. AC value is -20, and the factors that get you to -8. It's got to be, can it be 10 and 2? Which one is going to be negative? 10. Okay, break it down. -10p cubed plus 2p cubed, and then the front and the back obviously stay the same. Now we jump into the groups, factor groups. You okay with that, Ashwin? Got that look on your face like maybe confused. You okay with that breakdown? Okay. Factor groups, what's coming out of the first pair? 5p3, good. And then you get p3 minus 2? Good. And now we're taking out a +2. Don't ever forget this symbol. Please don't forget that symbol, okay? And you get p cubed minus 2. So they have p cubed minus 2 in common, and the 5p cubed plus 2 is the result, the factor pair, or the other factor. What do you guys think of that? Decent? Hmm? All right, let's jump to which one? 2H. We have a request for 2H. Well, that's a nice one. It's just a constant. Just like a letter, yeah. It's just like an apple. Apple pie, baby. Okay, so what's the... First of all, what's like your x value in like ax squared plus bx plus c? Which one is the x? R? R. Okay, so what's the a value? Okay, so the AC value would be 4 pi squared times -9, so you get -36 pi squared. What are the factors of -36? Basically, you don't even have to worry about the pi. What factors to -36 and gets you to 9? 12 and 3? Which one's negative? -12. Okay, break down this middle term as a -12 pi r plus 3 pi r, and then rewrite the front and the back. Jump into your factor groups. What's coming out of the first pair? 4 pi r, and you get pi r minus 3. Over here you can only take out a 3 and you get pi r minus 3. Take out pi r minus 3 binomial, and you get 4 pi r plus 3 factor group pair thing. Not too bad. Really bad. Too many weird like symbols? Okay, now where are we headed? Oh, we got to do one of these ones in the bottom. 3a? B? Okay, let this cosine x term equal big X. 4 big X squared minus 7 big X plus 3. You could factor that. AC value? 12. Factors that work? 3 and 4, and they both have to be negative. Okay. I'll just put the 4 first because it matches with the 4. I'll put the 3 next because it matches with the 3. I could take out a 4x. I get x minus 1. I could take out a 3, but I have to take out what kind of a 3? A negative 3, so that the signs switch and it matches. So I got an x minus 1 term, and I got a 4x minus 3 term, but I know that x is just this cosine x. So cosine x minus 1 and 4 cosine x minus 3. Basically the exact same process. You just sub in another value. Or just, it's like another appearance. It just looks different, but it's the same thing. So like looking at this next one, like what's your strategy here? I would just think of this no different than I would think of this. I would think of it the exact same way. Just the powers are going to be off. So however you would do a normal trinomial, just do the, okay? Oh, these ones. You'll have ones on the exam that look just like this. You'll have one in the written response that look just like that, exactly. It looks exactly like that. Like with different letters, but the exact same thing. It'll be a number, a binomial squared minus a different number, the same binomial plus a number. It's the exact same question. And for some reason, I want to use u. I don't know why. So you have 4u squared minus 5u plus 1. Why u? What say you? Okay, so what to do about this? What's the AC? 4? How's it going to break down? 1 and 4, obviously. And they both have to be negative. Okay, so put the 4 first. Put the 1 second. This works out nice. Take out a 4u. You get u minus 1. Take out a negative 1. You get u minus 1. 4u minus 1, u minus 1. That would be 1 mark out of 2. This would be 1 mark out of 2. Why? Because I didn't finish it off. I got to substitute 3x plus 1 in back into u and not forget to simplify it. Good. So I'm just going to take this over into the next space. 4u, which is 3x plus 1. And then we have 3x plus 1 minus 1. Oh, Chiming, thank you. I gotta start over. Whoa! I have tech problems. Tech problems, right? Okay, I forgot the minus 1, right? Chiming? Thank you, sir. And then u minus 1, so 3x plus 1 minus 1. Oh, big yawn. I'm not boring you, am I? Alright, so we distribute in that 4, you get a 12x plus 4 minus 1. And then I distributing a 1, that's not going to do anything, so I got a 3x plus 1 minus 1. So I got 12x plus 3, 3x. Am I done? Oh, nice. What can I do now? Take out a 3 out of the first one. What do you get? 4x plus 1. And then I still have a 3x over there. And then just to like sort of make it cute, you put the monomials together. And you got this. If you didn't do that from here to here, oh yeah, it wouldn't be the end of the world. I'd probably give you 2 out of 2. This is 2 out of 2. This is 2 out of 2. Smiley face. Yeah. Okay, so make sure you guys are practicing at least one of these. Okay, C, B, and D. No. Come on. He says, come on. This isn't beet juice. Shaquem knows. Shaquem knows. That's because the beet juice keeps me regular, if you know what I mean. You done copying there, Carl? Carl. Watch The Walking Dead? Okay, next lesson, go to the homework. Let's try some hard ones. Oh, this one here. Let's go to 3F on 252. 3F on 252. 252. What? This was on a quiz? It was A or X? Okay. Do you see a GCF? Stop. Do you see a GCF? Do you see a trinomial? Do you see a binomial? Okay. If it's a binomial, you have to check difference of squares. So is any even power a difference of squares? Yeah, so all even powers are squares. And then you just have to check 256. So go square root 256. Like, I know it's 16, but I got to give people strategies that don't know. Okay, so just yelling out 16 doesn't help. Gotta check it, right? So then you know it's going to be Z4, like half, right? Minus 16 and Z4 plus 16. Am I done? Keep going on which one? Good, difference is square. So we get a always half the power. Z2 minus 4, Z2 plus 4. And don't forget to copy the last one you didn't touch. It's still there. Oh, Daoud said I'm not done. Which one? Good, so what's it become? Z minus 2, Z plus 2. And now you know why I put lines through my Z's. Because they look identical to my 2's. Now I'm done? Make it look cuter? There's no outside monomials to make cute. Put a bow on it? No, that doesn't matter. That's like saying 3 times 4 is the same as 4 times 3. The order doesn't matter. Did you say commutativity? Oh, look at you. You have embraced your math nerd. Remember I told you last year to embrace it? You have embraced. What goes here? A chin? What are those? That's math, dude. He's. Look. That's as far as my art skills take me. That's a good picture. I'm a good artist. Okay, let's take a look at this one. Doable? Let's do I. I looks even more challenging. Next page. Check it out. Okay, when you look at this, you're automatically thinking to yourself, probably a difference of squares. At least you had that, right? If you don't see it, and if you see binomials, make a substitution. So if you see binomials, make a substitution. So then when we rewrite this, now it's a lot more familiar, right? Alright, so I'll let you guys try that one on your own. Which one did you want me to do? 4F? Oh, you actually, this is really cool because we're going to see one of these on the test where there's a decimal. If you're stuck, just do this. What is it? Like this? Because 16 times 16 is 256, right? And it just slides about decimals, right? So it's basically number sense. You don't need to think about the 0.0, you just think about the number sense. Like 256 is a perfect square, it's just slid over into some digits, like different place value, I mean. So you can just jump right into this. X squared minus 0.16, whoops, squared. And then you repeat that. Oh, I need a y in there too, right? Where did y go? Sorry, sorry, I had a little bit of a, oh my gosh. There we go. And this stuff on the right is on the aside. That's just on the side. And can I keep going on that? So then do another aside, 0.16 with the radical. Okay, so then we get x minus 0.4y, x plus 0.4y, and then repeat that last term again. You want me to keep going again? No, there's no square on x. You could keep going. It would be like root x minus 0.2 root y, that, but there's no point in doing that. Yeah, because then you have radicals. You made it more complex than you needed to. Stuff in highlight was just on the side. Okay, so don't get freaked out if you see decimal. You just think of what the number would be and then use a calculator to allow you to slide the decimals properly. Okay, any more on this section? We're going to move on. We got to get to lesson 5. Mm. I'm trying to find one. I say page 261. Okay, let's take a look at these. It says solve. And they're all degree 2 polynomials. What's that? Yeah, say it.
So since it's like a degree 2 polynomial, one side has to be 0, so you have to throw that 7 on the other.
Okay, good. So one side has to be 0. That's for solving degree 2 polynomials. What side do we pick? Good. Pick the side where the lead is positive. So in the first one, 2x squared, is that the lead? Circle the lead. That's positive. So I need to move the 7 to the left, switch the sign. Now, in general, you can't always factor the polynomial given to you. The ones that you're going to see on the test, you can. Okay, you will always be able to solve it by factoring. In the next unit, we'll learn strategies to solve where you can't factor. Okay, so we just have to factor this. The AC value is 14, and you got to get to 5. So it's 7 and 2. Which one's positive? So you end up with a positive 5? What? Yes, 7's positive. Good. Factor pair, you could take out just an x, right? And then you get 2x plus 7. Now I see 2x and 7 on the other side. Take out a negative. Then you get 2x plus 7. Factor out the 2x plus 7. And you have x minus 1. But what did I forget on each line? What did I forget on each line? Equals 0. Equals 0. Equals 0. So we're just factoring the left-hand side. This is the whole reason we factor. So that we, instead of solving a sum equals to 0, we solve a product equal to 0, because that's way easier to do. When you times two things and you get 0, that means they both are 0 or one of them is 0. Yeah, yeah. Yeah, you get full marks. It's kind of like it's your rough work, but you're showing me process, and then at the end you're being super clear. That's perfect. Every day these people call me. It's the 844 number. Every day they call me. They're probably trying to sell me something. Like that ringtone though? Just leave it and we just continue on. That'd be cool. Okay, we gotta finish this off. Okay, just ignore this. Keep going. So how to solve each one? Just so you ignore it. Yeah, you have to solve them individually. You can do this really quickly though, right? This is that zero, yeah, that zero product rule. So the second one's very easy. What's the answer to the second one? X equals 1. But the first one, a little bit more challenging. What if that 2 wasn't there? Negative 7. How do you get rid of a 2? So negative 7 halves for that one. Okay, if you don't believe me, take the positive 7, put it over here, it becomes minus 7, and then divide by 2. What about this one? Okay, so people are saying just FOIL out and then put everything on one side equals 0. That's an awesome strategy. That's awesome. But I'll just give you a little tip. Divide x plus 1 on both sides. and x is 6. Yeah. Problem is that only gives you one of the answers, right, Mahad? Yeah. Yeah. There's another answer that works, right? So yeah, what you guys were saying is better. But that was not a full solution, right? Because when you divide out x plus 1 here, you're assuming that x can't be negative 1, and it's not a good strategy mathematically. Oh my gosh. So my undo button. Let's just erase. Okay, so like you guys were saying, what's the better way to do this? Okay, so the first one's a difference of squares, so that's very easy. Everyone with me on that one? Now what do we do here? Dump everything to one side. Which side? You want to put to the right? Dump everything to the left, just like Beyonce would. And you get a minus 5x and a minus 6. These two are so easy. What is it? 1 and 6. Because the factors of 6 would be 2 and 3, or 1 and 5. But if it's 2 and 3, you'd have to have them both negative to get to negative 5, and that'll be a positive 6. So it has to be 6 and 1, and which one's negative? And then the answers, of course, are 6 and negative 1. Okay, so that's zero product rule. Now we got to do lesson 6 and 7. This is the nasty business. Okay, question 1 in the homework. This is on page 269. You have to know how to do these questions. Please highlight this word, restrictions. You have to know how to do restrictions. This is something you could put on your study sheet. For example, when you see the word restrictions, you want radicand greater or equal 0. Yeah. What's so funny over there? Carl. Okay, let's do 1D. What's the restrictions on this equation? The radicands have to be greater or equal 0. So do both of them separately. First one. It's just like a regular equation. Move the 9 over. And then divide by, so you get negative 9/2. If you want, put that in decimal so you're more comfortable, if that's something you need. Okay, now let's do the next one. Should I move the 1 over or the negative 2x over? Why? You don't want to divide by a negative, Mahad, because what happens? Signs will, and that's bizarre. So we don't worry ever about that. Move the negative lead over. Now divide by 2. Okay. And then put it into a decimal if that's easier for you. Now think about these two restrictions. You have to be bigger than negative 4.5 and smaller than 0.5. So on the number line, where would that be? Here's negative 4.5. Here's 0.5. You're bigger than, no, yeah. Let's do one at a time so everybody's clear. Your x is bigger than a negative 4. So which way are we going? Good. And let's do the second one. X, you always start with x. X is smaller or equal to 0.5. So which way do you go for that? So it's all this region in between. And then what does this extra equal to mean? Does that mean you get to touch the endpoints? So then you have to draw a circle. And you basically just draw a circle on each endpoint and connect. So that would be a good way to express this. What's the other way of expressing this? Put x in the middle, smaller than the right, bigger than the left. Better, Carl? Okay, now we're going to do the radical equations for about 10 minutes, and then I'll let you be free till the bell. 5D. We have a request for 5D. Who wants to do 5D? Okay, you have what I would deem relatively easy radical equation. Okay, recall the steps for radical equations. Oh, good one. Number 1, isolate. Number 2, square both sides. Number 3, and number 4. Good. Okay, so let's do step 1. Is it isolated? Okay, please do that. What's in the way? And is the x minus 2 term positive? Okay, so it makes sense just to put the 4 over there. So on the left-hand side, you just have the root of x minus 2, and on the right-hand side, you have x minus 4. Now we got to do the second step, which is square. So squaring the left is amazing. You're just like, wow, that feels good. That was so easy. And the right-hand side, I'm going to do what at least one of you will do tomorrow, but don't let it be you. Don't let this be you tomorrow. How wrong is that? What's it missing? Missing the middle. Good. So don't be that person tomorrow. I know there's going to be one of you. There's always one. Fred, don't let it be you, okay? I'm going to be watching. But it's a perfect square. We talked about this at the beginning of class. It would be minus 4x twice in the FOIL, right? You get that minus 8x. Now it's like the zero product rule stuff. You got to move everything to the one side. Which side should we move it? Good. Leave the left 0 so that your x squared term stays positive. So you're going to minus x, you get minus 9x. And you're going to plus 2, you get 18. Did this on a quiz? Minus 3 and a minus 6? We did this on a quiz. You guys have said that like 4 times today. So the homework and the quizzes. I didn't do it. It was Mr. Trimble. He's the master. Math master. Are we done? Because we only made it to step 3. So now we need to verify. Okay, so what does it mean to verify? It means the left-hand side has to equal the right-hand side when you check. So let me switch colors and let's try this. 4 plus, let's start with 3. 3 minus 2 equals 3. 4 plus root 1 equals 3. 5 does not equal 3. So instead of saying that 3 is a loser or rejected, we say that it's being extra. Then you lose a mark. Carl. You gotta watch Walking Dead, Carl. Yeah, you could put rejected, Carl. Okay, 4 plus 6 minus 2 equals 6. 4 plus root 4 equals 6. 4 plus 2 is definitely 6. 6 equals 6. x equals 6 solution. Okay, let's go to part 2 and try one of the hard ones where there's more than one radical. So if there's more than one radical, you have to repeat the second step twice. Okay, page 281, number 6A. This looks like it was on the quiz. And was 6B on the quiz? You would have just did this. Hey, Daoud? Wow. No, the second one was not on the quiz, but it looks similar. Okay, let's do the second one. Before we do the second one, what would you do for the first one? Yeah, you have to have a radical on either side. It's just a tad bit easier. Yeah. This one was on the quiz. This one was on the quiz. Why don't we do this one? I'll be your group. Okay, let's just do 282, question C. Okay. So step 1, isolate the radical. I would just say make sure you only have one radical on either side. Okay. Okay, so then step 2, square both sides. The left is a dream. The right is not so much of a dream. And I would just recommend repeating the factor and foiling it out. So we just squared both sides. The left side is nice. The right side, repeat the factor. Now we can distribute and simplify the right. We got a 4. And then the middle term repeats itself. So what do you have there? 4 of the 2p minus 1 in a radical. Do you see that? And then the last, those radicals undo each other and you're just left with the radicand. Are you a radicand or are you a radicant? That's what I want to know. I'm just trash. Okay, so again, the left side is amazing. The right stuff, what can you do with the right stuff in blue?
You can kind of like mix it and then throw it on the other side.
Okay, put it together. So 4 minus 1, 3, plus a 2p, and then we have this 4 with the radical attached. So we are now in step 2 again, which is, no, step 1 again. Isolate the radical. So I'm going to subtract the 2p, and you get 2p. I'm going to subtract a 3, and I'm going to get 2 on the left. And on the right, I have this over here. Now I can do step 2, which is square both sides. Okay, so if you want, just repeat the factor on the left. And on the right, I really don't want you to forget. I bet there's more than one of you who forgets this tomorrow. Don't forget to square the coefficient. So you get 16 2p minus 1. And I've even seen the craziest stuff. I've seen people distributing into radicals. You don't call out their name. God, no. Okay, so please don't make this mistake. Always remember to square that coefficient. And then now we have to distribute and solve and zero product rule, all that stuff. There's so much going on. On the right, you have a 32p. minus 16, and on the left we have this perfect square, so 4p squared and a 4, and then how does the middle double up? 4p times 2 is 8p. Dump everything to the left so that your 4p squared stays positive. So we have to minus 32 from 8. Oh, thank you, Mahad. And then add 16, you get positive 20. I see a GCF. I'm ecstatic right now. And then I see inspection. Inspection is lovely. And then from the inspection, I get the answers 5 and 1. Now I have to verify. Probably the longest algebra question you guys have had to date in your lives. So if you see the structure, you have an initial squaring. You get through some stuff. You have another squaring. You get through some stuff. And then you have to factor a quadratic and solve and then verify. Okay? So checking 5. 4 times 5 is 20, so 25. And then we have root 9. 2 times 5 is 10 minus 1 is 9. So we have 5 equals 2 plus 3. Okay, so 5 worked. Trying this again. This is just me verifying. Now checking 1. Plug in a 1, you get 4, so 4 plus 5 is 9. Plugging in a 1, I get 2 times 1 is 2, 2 minus 1 is 1, root 1. 3 equals 2 plus 1. They both work. Both are solutions.
So the only reason why I get this question is because you have to verify, you have to replay back in it, and it's just extra work.
All right, so you have the rest of the block.